Okay, so time to talk about fiber types. And so we've talked a little bit about it earlier in the semester when we were talking about oxidative capacity, I think during week 2. But we're going to get a little more specific here. So 3 objectives. What are the 3 primary types of skeletal muscle fibers? How do genetics play a role? And is it possible to change fiber type? Okay, so really there's a couple of things. So muscle fiber type is determined by the specific type of myosin. And on that specific type of myosin, each one of them has a specific ATPase, right? So remember, ATPase is the enzyme that breaks down ATP. Fast motor units have, or fast muscle fibers, or however you want to look at it, have a fast-acting enzyme. Slow has a slow-acting enzyme. All right. Another thing that determines this is the amount of specific bioenergetic enzymes. Okay, and so to put that in different terms, we're going to classify our fiber types as oxidative or glycolytic. So if it's oxidative, these are muscle fibers that can create a lot of energy through the electron transport system. If they're glycolytic, they produce a lot of energy through glycolytic systems. Those use different enzymes. Okay, and so you'll have these muscle fibers will have one or the other usually. All right. So we can differentiate them by the type of myosin. Like I said, you've got slow versus fast. And we've got 3 main types that we're going to talk about. So 1, 2A, and 2X. Now it's important to know that we used to call 2X 2B, but now it's generally referred to as 2X. But another interesting thing as you look on this is that, hey, we've got a 2C on here. All right, there's some debate as to how many actual muscle fiber types there are. It looks like there might be 6 or 7 or 8, definitely multiple, more than 3. But the differences are pretty slight. Okay, and so we generally classify them, at least right now, as type 1, type 2A, and type 2X. Okay, so remember just a second ago I said that there are glycolytic enzymes and there are oxidative enzymes. Okay, and so if we've got type 1 and type 2 and type 3, type 2A, type 2X, the blue bars represent the quantity or the amount or the concentration of glycolytic enzymes. So phosphorylase, phosphofructokinase, remember we talked about that, and lactate dehydrogenase, those are glycolytic enzymes. And then look at the relative concentrations and compare between type 1 and type 2X. Okay, type 1 has a really low concentration. Type 2X has high. Type 2A, on the other hand, has a fair amount, but it's not as much as type 2X. Now, if we did the same thing, but now we look at the oxidative profiles, okay, so it's the same figure, but now green, just to be clear, green represents those oxidative enzymes. So succinate, dehydrogenase, and citrate synthase. Okay, type 1 and type 2A have high levels of those oxidative enzymes, whereas type 2X does not. Okay, and so what this means is, if we just look at type 1, doesn't really do a whole lot with glycolysis or can't do a lot of glycolytic activity, but it can do a whole lot of activity in the electron transport chain. Conversely, type 2X does a ton of work via glycolysis, but not so much with the electron transport chain. And then type 2A is kind of a combination of the two. So we can look at this a different way. We can look at the motor units, okay? So we can classify them as fast fatigable, which would be your type 2X, fast fatigue resistant, which is type 2A, or just slow and very fatigue resistant, which is type 1. We can look at their metabolic activity or their enzyme activity that we just went through. So we've got strictly glycolytic, which is type 2X, or highly glycolytic is probably a better way to put it. Highly oxidative, which is type 1, and then a combination of the two, which is our type 2A. And then we've got their type of isoform or the type of myosin. Just think of it that way, and they each have their own unique type of myosin. So to put this in a table, we can look at this. All right, so slow oxidative, they're slow. They are very resistant to fatigue. They have low ATPase activity, meaning it's pretty slow. They have the capacity to do lots of oxidative work, so on and so forth, right? And I'm not going to go through each of these little things. Now, the reason that you've got red here and white here is red, that's an indicator that there's lots of myoglobin. So type 1 and type 2A have relatively high amounts of myoglobin. Okay, now type 1 fibers are going to have characteristics that let them use oxygen. Okay, they're fatigue resistant, they're aerobic. So they have lots of capillaries, lots of myoglobin, lots of mitochondria. Conversely, type 2X, they don't have large numbers of any of these things because, well, they're not going to use the oxygen. So if you're not going to use the oxygen, you don't need the mitochondria, you don't need the capillaries, you don't need the myoglobin. So then let's tie this into what kind of athlete we can all become. All right. So this is Eliud Kipchoge, best marathon long distance runner ever in the history of ever. This dude has run 26 miles, 385 yards in under 2 hours. Okay, to give you an idea of how fast that is, go to the rack, turn the treadmill all the way up to how fast it goes, which I believe is 12 miles an hour, and then run on it for 2 hours. Okay, he's done that. The problem is you've only gone 25 miles if you could do that. He's done over 26 in that time. So your treadmill can't even go as fast as he's run for 2 straight hours. He's ridiculous. And I believe he's won the last 2 Olympics. He holds the world record in the marathon. Like he's elite. He's the elite of the elite. So he is all type 1 muscle fiber, or pretty close to it, right? So he's got slow, low power, but it's relatively efficient. He's got high oxidative capacity. He's going to have high mitochondrial density because he's able to use all of the oxygen and produce all of the ATP. Okay, so this is an endurance athlete. So small muscle mass, like you look at him, he's nothing, right? He's very small. I don't know what his height and weight is, but he's going to have a lot of type 1 fibers, but he's also going to have a high amount of endurance. Okay. Now, if you look at the percentage of type 1 fibers by athlete, there's a pretty distinct pattern here. Okay. And so this is all track and field. I'm just doing this because you've got untrained. So untrained is on average about 50-50. So people that specialize in jumps and throws and sprinting, they have relatively small amounts of type 1 fiber, but they're going to have lots of type 2 fibers. So just think if it's not, the empty space here, well, if I could draw a straight line, that is all type 2 fiber, the fast, the powerful muscle fibers. Okay, whereas someone that's a marathoner, they might have over 80% type 1 fibers. So then the question is, well, can you decide, hey, I want to be a sprinter, or I want to be a marathoner, and I want to be really, really good at it? The answer is probably not. Okay, you're just kind of predetermined. So if you wanted to be a power lifter, but your parents were runners and look like runners, you can get mad at your parents. Okay, so endurance athletes, small muscle mass relative to fiber size, lots of type 1, high muscular endurance, whereas if you're a strength and power athlete, you're going to be the reverse. You're going to have large muscle fibers, you're going to be big, and you're going to have a high percentage of type 2 fibers. Okay, so again, is it possible to change this? And the answer is maybe. All right, but it seems to only go one way. All right, so there's a study where they had people cycle 1 hour a day, 4 days a week for 5 months. Okay, so it's quite a while. So average person in this study started with 32% type 1 fibers. At the end of it, they went to 36. Okay, so they increased. And they even had one person that went from 23% type 1 up to 32% type 1. That's a big change. Okay, so that's the way things seem to go, is that you can change type 2 into type 1, but it's really difficult, if not impossible, to go the other way. Okay, and so in order to change the type of muscle fiber you've got, they have to start changing their gene expression. And we're not going to dive into this, but that's not an easy thing. Okay, now you might see some changes in the myosin, but you also need to have changes within that muscle fiber, and it can take months and years. Okay, now depending on what muscle you use, you can shift towards that, right? So if you're endurance training, you're going to shift towards those slow isoforms. If you don't use it as much, you might have some fast isoforms, but it's not like you're going to go from, it's not like Kipchoge is going to go from being world-class marathoner to a gold medalist at any sort of weightlifting competition. It's just not going to happen. Okay, and so you've got a starting point, and really the way I like to think about this is that there's a range. There is a range that you fall in. Okay, and so depending on your parents, you're going to fall at some point along this spectrum as to where you're at. Okay, and so here's our spectrum, and then let's just say I started here. Okay, my range might be something like this, where I can, kind of bounce around a little bit between type 2A dominant and type 1 dominant, whereas some of you who maybe, if there's somebody in here whose dad plays in the NFL and whose mom was, through shot put or something in college, okay, you might be more disposed to be over here. All right, so there is some change, not big changes, easier to go from 2 to 1, but if you're kind of endurance heavy, so someone like me, I'm not going to become this big time powerlifter, most likely. And so you might be able to build an elite endurance athlete, but you're not going to be able to make an elite power athlete, okay, because they're born. And again, this is genetics, all right? And for the most part, it's not just saying, hey, you wake up and you're going to be this amazing athlete. You've still got to put in the work. I want to make that clear. So there you go. Muscle fiber types.